More on how to use the TI graphing calculator. Again, I am using a TI-84 plus CE, but a lot of what I'm going to do is going to apply to any graphing calculator. Now, one of my favorite things about the graphing calculator are second entry and second answer. Let's say I'm typing in some really complicated bit of algebra, plus 3 to the, that's going to be too big, let's do 3 to the 4th, minus 4 to the 3rd, over 6. Now, this is just a random string of numbers that I put in. I'm not worried too much about the details. But let's say I type in something complicated, and then I look at that and say, oh, that was supposed to be a minus sign. I accidentally typed a plus. We've all done it sometimes. I don't necessarily want to have to retype that. There's a lot of stuff going on there. So if you've mistyped something, I'm going to come down here where it says enter, and above that you'll notice it says entry. So I'm going to hit second, enter, and that's going to bring me up exactly what I typed. So I can now just use my cursor and come back here and change it to what I intend it to have so that I don't have to go in and change the entire line. So again, I like to use that where, again, it's second, enter, to pull up the line that I've just typed in. What I use the most often, though, is second answer. Let's say I've done a very complicated string of arithmetic, and I now need to use this number again. I could type in 73.833333, but I'm a very lazy person. I don't want to have to do that. So instead, you'll notice over my negative sign, it says ANS. So if I hit second, that negative sign, again, to get those blue things, I hit second first. What that is going to do is I can call up, oops, sorry about that, I hit my video camera. If I hit that, I can get that answer without having to retype it. This is really nice for iterative problems. In calculus, we have certain problems where I might have a problem that has x to the n minus x to the n squared minus 4 times x to the n plus 1 over 2 x to the n, minus 6. And that's going to give me my next iteration. So what I tell students, that first iteration, let's say my first iteration is 0.15, I'm just going to type that in. And then let's type in that whole hideous thing, but everywhere I see that little x to the n, I'm going to use that answer. So I'm going to hit second answer, minus, to do a fraction, I'm going to hit alpha y1 to get my menu, select that first option. Now I am going to use parentheses here, second answer, quantity squared, because I always tell students if I've got parentheses here, I want to have parentheses here. So minus 4 in parentheses answer plus 1, and then on the bottom of my fraction, 2 in parentheses second answer minus 6. So again, I have ANS instead of all those x sub n's, but otherwise this looks exactly like what I just wrote out by hand. And let's hit enter. The nice thing about this is for this type of problem, if I have to do 3 or 4 iterations, since I used answer, I can now hit second entry. It looks exactly the same here, but now ANS, instead of referring to 0.51, is referring to the 0.2241, etc. I don't have to type that number, and I definitely don't have to retype my expression. And I can just keep hitting second enter and get as many iterations as I want. And really, it's just that first one that I have to type in slowly and carefully. And I really like to be able to do that for problems like this because it saves me so much time and effort. So again, second enter will pull up my previous expression that I typed in, and that second negative for answer will pull up the number that I immediately used. Now let's say I have to remember 2 numbers. In this case, I am probably going to use variables to save it. So let's say I've got a pretty complicated number here. I'm just going to type in some random values here because I don't really care what the number is. And I'm going to use this little option that says STO arrow. going to allow me to do is to store it. And I'm going to store it as a letter. So here, let's go ahead and pick alpha and pick it as A. So I'm going to store that value as A. And let's hit another number here. Again, I don't really care what the number is. I'm just typing in some random numbers. And let's hit then store. And let's store that as alpha B. So if I need to do computations now with these two numbers, I could type in, say, 5A minus 6B divided by, let's do divided by 4, make it a little bit more interesting. And then we can continue. But that means if I have numbers, I can save them as letters so that I don't have to type them in. And again, that's particularly useful if I have long, complicated numbers. One note of caution. This is something I always tell my students. We've got our x, and I use that when I'm graphing. But if I'm trying to solve x plus 5 minus 2x minus 7 plus 6, if I try typing that in here, let's type that in, subtract 2x, subtract 7 plus 6. Again, I'm using my subtraction sign, not my negative sign. If I hit enter, is that actually my answer? You might think it is, but it actually isn't. Because if I hit just x, my calculator thinks that x has a value. As I tell my students, the only time really that you should be using that x is if I'm graphing. There are some times in later classes where we can use it as well. But for most of the classes I teach, I tell students only use the x if you're graphing. If you put it in here and try to use that to solve a basic algebra problem, again, my calculator thinks x has a value. And so 14 is not correct, unless, of course, x actually is negative 10. So again, do note, word of caution, my calculator does think x has a value if I'm just here in normal computational mode.